Hello everyone, let's talk about another medium problem on Leetcode today. Sort an array, Leetcode 912. In this problem, we are given an array of integer nums. Then we have to sort the array in ascending order and return it. Then they say that we must solve this problem without using built-in functions in O and log n time complexity and with the smallest space complexity possible. And then they have given some examples as well. In example 1, we can see that input array is 5, 2, 3, 1 and output array is a sorted array 1, 2, 3, 5. Now let's see how we can actually solve this problem. First thing is we cannot use any built-in functions. So that means we can't use any sort algorithm or anything. We have to implement our own. And second thing is the time complexity should be O of n log n. So when they say that, then there are very few algorithms which can actually make that happen. So first algorithm that comes to mind with this time complexity is quicksort, where the time complexity in the average case can be n log n, but in the worst case can be O of n square. And that worst case comes when the pivot is actually a smallest or largest element in the array. Another algorithm can be merge sort. In this case, time complexity is O of n log n, be it worst case, average case, or best case. Another approach can be that we use the heap sort. In this case, we can build the heap or specifically min heap, which takes O of n time. And then to get the sorted array, we can actually start removing the minimum elements from the heap. And that takes O of n log n time. And one more approach we can think of is we can use the binary search tree. In that case, when we are building the tree, that takes O of n log n time. But then we run the in order traversal and that takes O of n time. So overall, the time complexity will be O of n log n again. And today, let's focus on merge sort, where we will actually explore the divide and conquer approach. And I will try to cover other sorting algorithms in the coming days. Now let's focus on merge sort. Merge sort is one of the older known algorithms, known since 1945. It follows divide and conquer paradigm, in which we actually keep on dividing the array into two parts till it is not divisible anymore. That is when we reach to the individual elements, and then we sort these individual arrays and combine them, and finally get the sorted array. Now let's look at it with an example. So in this case, we can see that the array size is 8. So we will divide it into two arrays of size 4. It doesn't matter if the array size is odd. For example, if it was 9, we will just say 5 on left side and then 4 on right side and then keep the algorithm moving. Then we will recursively divide this array into two parts as well. So we will get 7, 4, 6, 1. Similarly on the right side as well. And then we again divide these arrays of size 2 into one each. And now we are actually done with the divide step because now we cannot divide these elements anymore because they are a single element. So this is our base case. And now that we are done with the divide phase, let's jump into the combine or conquer or merge phase, where we actually start merging the elements. So now for the combine, we will actually compare the two elements. So for example, we can see that 4 is less than 7. And for sorting in the ascending order, we want the smaller elements first, that is 4, and then the larger value, that is 7. Also, note that we are recursing back to this point, but I'm showing the combine step like this for the clarity. But basically, when we see 4 and 7 as two separate elements, that is coming from the previous step where we see 7 and 4, and we combine this back to 4 and 7. Similarly, we had broken down 6 and 1 earlier, and now we combine it back to the sorted array with values 1 and 6. Similarly for 3 and 5 and 8 and 2. And now we are done with the combine on this level. So we will recurse back and try to combine these arrays of size 2 into arrays of size 4 on the left and right side respectively. Note that for each combine step, we are actually creating a temporary array to store the combined result in an array. So we can say that now we are actually combining two arrays of size 2. So we create a temporary array of size 4. And now we can actually follow the two-pointer approach to combine the two sorted arrays into a sorted array. So we can take one pointer in the array with values 4 and 7 and another pointer in arrays with value 1 and 6. And now we can start combining the two arrays by comparing the values at the corresponding pointers and fill in the smaller value into the combined array and incrementing the corresponding pointer. So we have first pointer on 4 and second pointer on 1. So which value is smaller here? So we can see that between 1 and 4, it is 1. So we actually save 1 here and move this pointer to 6. Now between 4 and 6, we can see that 4 is smaller. So we actually save 4 and move the pointer here. And now we can see that between 6 and 7, it is 6. So we store the value 6 here. And now we are actually out of bound of this one. And there is only 7 remaining. So we actually insert 7 into this temporary array. Similarly, we will do it for the right side as well. And now we recurse back and we are at the final step where we will actually merge these two arrays of size 4 as well and finally get a sorted array as an output. So this is how the whole merge sort algorithm will work. Now let's jump into the code part. Now let's define our merge sort function. It takes nums array in it. And now we will start the merge sort with left and right boundaries, left being 0 and right being n minus 1, where n is the length of the array. Because we pass in the left and right boundary and then find the midpoint and then divide the array on that midpoint. So now let's write down the merge sort helper, which takes an array and left and right boundaries. So first thing we will do is we will check if left is greater than equal to right. At that time we will stop and return. And it corresponds to the point that when we are dividing the array into two parts, the array size cannot be less than 1. So it cannot be 0 or negative. Now that we have handled the case, let's calculate the midpoint between left and right. We can also do left plus right by 2, but this way we avoid the overflow. And now we divide the array into two parts, left and right, using the merge sort function. So this is a divide step. So we split the array into the left side and the right side, and note that mid is inclusive in the left subarray. So that's why we are doing mid plus 1 here. And finally, we do the merge, where we actually combine these divided arrays. We don't have to pass mid in merge because we can calculate mid from left and right, but I'm still passing it so that we don't have to do the same calculation again. So now comes the merge logic. So we will need nums, left, mid, and right pointers. And now we have to merge the left and right subarrays. And to do that, we need a copy from the nums array. So left array holds elements from the original array from left to middle, and right array holds the elements from middle plus 1 to right, because middle is actually inclusive in left array, right? So let's define the size of left and right subarrays. So it will be mid minus left plus 1, because mid pointer is actually included on the left side. So if we write it like, so this is the left pointer, this is mid, and this is right. So we want mid to be included. So it will be mid minus left plus 1 for mid pointer, right? And similarly for right, it will be right minus mid. And we are not doing plus 1 here because we don't want mid to be included on the right side. So we will just do int and right is equal to right minus mid, because right is greater than mid, right? Now we initialize left and right subarrays. And now to copy the values from nums array, we will use the Java utility systems.array copy. In the Java doc, we can see that for system.array copy, we have to give the source array, then we have to give the source position, then destination array, and then we have to also give the destination position and number of elements we want to actually copy from source to destination. So let's apply it here. So for left side, we will do system.array copy, and we will copy the nums array from left pointer to left array from position 0, and we have to fill in n left elements, right? Because that's the size of the left array. Similarly, for right, we will copy from mid plus 1, because this is what we copied in the merge sort for the right side. And this time we will just copy to the right array from position 0 to n right, because that whole array was empty. So now we will fill it in. And once we do that, we can take two pointers, I for left array and j for right array. So initially both of them will be equal to 0, because we will use two pointer approach on these left and right subarrays, and merge these two arrays and update the nums array between left and right boundary based on these. Let's define k as an iterator for updating the values in the nums array. So initially this value will be equal to left, and at maximum it will go till right boundary. Now we will follow the two pointer approach. So we will say while I is less than n left and j is less than n right. Now we will check for the smaller values between left and right subarrays. So we will see if left array I is smaller than right array j, then we will actually fill in left array, right? Because that is smaller. Otherwise, we will just fill in right array j, and we also have to increment the I pointer in case we choose the left array, and similarly we will increment the j pointer in case we choose the value from right subarray, and we will increment the k pointer anyways, right? And in case there are still some elements remaining in left subarray, we will fill it into the nums array. So we will just say if I is still less than n left, then we will fill in the value from left array and increment both I and k. And similarly, we will do the same for right side as well. So now we are done with the merge step. Now we have to make a call to this merge sort function. So we can just say merge sort and pass in num. So this will do in place. And because Leetcode expects us to return the sorted integer array, what we can do is we can actually make a copy of nums array. So this way we don't modify the nums array for the immutability reasons. And we can say that arrays dot copy of, and in this case we can just pass nums and nums dot length because we want to copy the full array. And once we do that, we can just pass the copy to this function and then just return copy, right? And this should do it. Now let's try to run this code. Hopefully there are no typos. But there are. So it says that cannot find symbol system.array copy. Because C should be small for copy. Let's try again. Cool. Let's submit this code. Okay, the output shows that it should be 3 rather than -2. So that means I'm copying the wrong value from the right subarray because I'm getting -2 from the left side and 3 is coming from the right subarray. Oh, and it is because of this copy paste error. So I should be using right array here, not the left array. So when the right elements are remaining, I should be using the values from the right side. Now let's submit this code again. Awesome. So in terms of time complexity, it will be O of n log n, where n is the number of elements in the array. And the reason for this is in each recursive call, we actually split the array into two halves. And that takes O of 1 time because we are just updating the left and right boundaries, but we are doing it for log n levels. And the reason for this is at each level, we are actually dividing the array size by 2. And eventually, at certain level x, number of elements in array becomes 1. Eventually, n by 2 to the power of x becomes 1, right? So n is equal to 2 to the power of x. So now we take logarithm of both sides. So log 2n is equal to x. So that's how number of levels is equal to log n. So dividing the array elements overall takes log of n time. But at each step, when we are recursing back, we are also merging two sorted arrays that takes O of n time. And because of this, overall time complexity is O of n log n. That is log n into n time. And in terms of space complexity, it will be O of n because we are actually creating these temporary arrays at each call, and that takes O of n time. Also, we are having this log n recursive stack, which will also take O of log n time. So overall, it will be O of n. I hope this video was useful to you. If it was, please like and subscribe. The code link is in the description below. Have a nice time. Thank you.